25 meters below the Pacific, off Japan's westernmost island. A diver named Kihachiro Aratake was scouting hammerhead shark sites in 1986 when his mask tilted down and he saw walls. Not cliffs, walls. Flat plains dropping 90 degrees, corners cutting precise right angles in sandstone that's 20 million years old. Steps rising in perfect terraces like someone carved a pyramid and let the ocean take it. He surfaced. He told the University of the Ryukyus. Professor Masaki Kimura dove that same year and he spent 15 years mapping what he calls a city. But Robert Schoss from Boston University dove it too and says it's fracture lines and erosion doing what they always do in earthquake zones. 38 years later, nobody settled it. Both governments, the Japanese Agency for Cultural Affairs and Okinawa Prefecture, won't touch it. No official recognition, no funding, no excavation team, just divers and debate. 12 features sit down there that keep splitting the room, structures that don't fit either story cleanly, angles that geology explains until you see them together, gaps where artifacts should be if humans worked the stone, but currents that could have swept anything away. Let's walk through them. Aratake runs the Sao West Dive Center in Kubura on Yonaguni's western tip. He wasn't looking for ruins. He was scouting sites for tourists who come every winter to see the hammerhead shark migration between January and March. The sharks gather in schools of 50 to 100 individuals circling the southern waters. That's the draw. That's the business. Aratake swam deeper than usual, following a ridge, and when he crossed 30 feet, the ridge became something else, massive, organized. He later told reporters he felt emotional. He'd dived these waters for years and never seen it. The formation sits 100 meters offshore from Arakawabana Cape, also called Aragabana in the local Yonaguni dialect. The cape marks the southern tip of the island. The monument's main face orients south-southeast. When you approach from the north side where dive boats anchor, you descend through blue water with visibility ranging from 10 to 30 meters depending on season. Winter brings the clearest water but also the strongest currents. Divers report being swept sideways at speeds that make hovering impossible. You drift along the structure finning hard just to maintain position. The current roars past your ears. Your regulator hisses louder under the load. At 35 feet depth, the north wall rises almost vertical. It towers from the seafloor at 82 feet all the way to 16 feet below the surface. That's a 66-foot vertical drop. Straight, no taper. Your brain registers building even though your training says rock. It's the westernmost point of Japan. The island measures roughly 11 kilometers east to west. Maximum elevation hits 231 meters. The Ryukyu Islands stretch in an arc following the subduction zone, where the Eurasian plate slides under the Philippine Sea Plate. That collision zone generates continuous seismic activity. Yonaguni recorded a magnitude 7.8 earthquake in 1966. In 1995, parts of the island were destroyed by another major quake. The 1771 Mewa tsunami struck with waves estimated at 30 meters high, killing over 12,000 people across the Ryukyus. The sandstone that forms the monument belongs to the Yaeyama group, deposited during the lower Miocene epoch roughly 20 million years ago. During the last glacial maximum around 20,000 years ago, global sea levels dropped 120 meters below present levels. Yonaguni connected to Taiwan via a land bridge. As the ice sheets melted from 18,000 to 8,000 years ago, seas rose rapidly. Anything sitting at current depths would have been submerged sometime in that window. If you value documented underwater archaeology and geological controversy like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the 2019 topographical analysis by Takayuki Ogata and colleagues published in eJournal GEO Volume 15, Issue 1 pages 44 through 54, which conducted digital, elevation modeling, and field investigations at 3 geosites on Yonaguni Island, including Saninudai, where they found step formations identical to the underwater monument, and from Robert Schock's direct field research published on his university page at robertskoch.com, where he details his multiple dive expeditions and hammer and chisel rock sampling at the site itself. Now back to the information. The main terrace measures 150 meters long, 40 meters wide, 27 meters tall. That's 490 feet by 130 feet by 90 feet. The top sits 5 meters below the surface, high tide. It's not a single block. It's connected bedrock, carved or fractured into a rectangular platform. Most of its surface runs in broad, flat steps. Vertical walls drop without taper. When you're neutrally buoyant at 35 feet, and that north face towers above you almost to the surface, your brain reads architecture. The sandstone and mudstone belong to the lower Miocene Yaeyama group deposited 20 million years ago. Earthquakes fracture rock in regular patterns here. The island sits on the subduction zone where the Eurasian plate meets the Philippine Sea Plate. Schoch photographed parallel bedding planes and vertically oriented joints that cleave the stone into rectangles. He says it's textbook stratigraphy. But here's the issue. Those joints run island-wide. The monument's the only place where they stack into a shape this unified. Takayuki Ogata's team in 2019 used digital elevation models and found matching step formations at the Saninudai geosite on the south coast above water. They concluded natural weathering on bedding and joints, but even in their paper they note the concentration. On land, the features scatter. Underwater, they organize. That's the thing nobody reconciles. If it's purely natural, why does it look curated? Each pillar measures roughly 2 meters in diameter. They're positioned near the northern approach where divers first encounter the monument. Schoch says strong currents move boulders regularly, and the sea can stand rocks upright. He's documented this process in other coastal zones where storm surges lift multi-ton blocks and deposit them in improbable positions. During the 2011 Tohoku tsunami, boulders weighing 20 tons were moved inland over 100 meters in some locations. The force exists. Kimura says these were placed. The photos show them aligned, not tilted, not eroded into soft lumps, clean columnar forms. If they fell from a higher shelf and landed that way, you'd expect rubble at the base, broken pieces from impact. Divers report the area around them is swept clean. Currents run fierce here, especially in winter, when visibility drops and the water howls past the monument, pulling masts sideways. Wind speeds during winter typhoons exceed 150 kilometers per hour. Wave heights top 10 meters. That energy reaches the seafloor even at 25-meter depth. The pillars have survived it. They stand. Maybe currents clear debris. Maybe they positioned the pillars. Either story asks you to accept coincidence. 2 stones, same height, same spacing, both upright. The spacing between them measures roughly 3 meters. That's too consistent for random tumbling. When rocks fall, they scatter. These didn't. The base of each pillar sits flush with the surrounding platform, no visible void beneath no sign they punched through from above. If they dropped from a collapse, you'd see fracture patterns radiating from impact. The platform is intact. But loop roads don't usually circle structures. They tend to follow the weakest seam and wander. This one doesn't wander. It holds the line. At one section, it turns a corner and keeps the same width through the turn. Erosion patterns usually shift when orientation changes, because wave action and current hit from different angles. This didn't. 2 round holes sit at its edge. Each hole measures roughly 60 centimeters across. Photographs show they're circular, not elliptical. The walls descend vertically into the stone. Kimura's team says these look like post holes or anchor points for wedge splitting. Old quarry technique where you drill holes, insert wooden wedges, soak them so they expand and crack the stone along a line. Egyptian quarries show this method. Greek marble quarries in Paros used it. You drill holes at regular intervals along the desired break line. You pound and dry wooden wedges. You soak them with water. The wood swells. The pressure splits the rock clean. It's documented in Bronze Age sites across the Mediterranean and in ancient Asian stone working traditions. The technique requires knowing stone grain and fracture planes. It leaves signature marks, round drill holes in linear patterns, and the split face shows less weathering than natural breaks. Rows of smaller holes run nearby in a straight line. Kimura counts 7 smaller holes, each roughly 10 centimeters in diameter, spaced at 40 centimeter intervals. That's systematic. Schoch says the large holes were scoured by eddies. He says marine organisms exploit seams and drill through softer spots. Both mechanisms exist. Tidal eddies can bore potholes in rock where turbulence concentrates. Mollusks and sea urchins drill into stone to create burrows. Biological boring is common in the intertidal zone, but the spacing bothers people. The 2 large holes align with the triangle's geometry. They sit at the apex corners, not randomly scattered across the surface. The row of smaller holes is linear, not random. If biology made them, you'd expect clustering near nutrient flow or chaotic scatter. Urchins don't drill in straight lines. If eddies made them, you'd expect variation in size where turbulence peaked. Pothole size correlates with eddy strength, which varies with local topography. These are uniform. The depth of each large hole measures approximately 80 centimeters. A diver can fit a forearm inside. The walls are smooth, not jagged. Natural weathering usually leaves rough surfaces where softer minerals erode, faster creating texture. These don't have that texture. They're polished. Water flow can polish stone, but typically in areas of constant current exposure. The triangle pool sits on the upper terrace where current flow is less intense than on vertical faces. The polishing doesn't match the hydraulic environment. The absence of loose rubble on the flat surfaces. When rock fractures naturally, it leaves blocks sitting where they fell. Earthquake zones especially pile debris. The monument's terraces are bare. Schoch notes the strong currents and says they swept it. Hancock and others say that's convenient. It explains away the thing that would prove natural origin. If the stone breaks and falls, where's the pile? If the current moves it, where did it go? The seafloor around the base should be littered. Divers describe scattered boulders offshore, but not the density you'd expect from 27 meters of vertical fracture. Maybe it's offshore beyond the search grid. Maybe it never fell because someone removed it while working the stone. Neither answer closes the gap. Sharp angles radiate from the center. Kimura says it's a carved marker. Others say pareidolia. The human brain sees patterns and assigns meaning to clouds and rocks and coastlines. The old man of the mountain in New Hampshire was a natural face that collapsed in 2003. The Viking on Mars photographed by Viking 1 in 1976 was shadow on a hill confirmed by later high-resolution imagery. Human brains evolved to recognize faces and patterns for survival. We see agency where there's only process. But the turtle isn't just a vague resemblance, it's geometric. Star points extend at regular intervals. Measurements taken from aerial drone footage show 5 points radiating at approximately 72-degree angles. That's consistent with pentagonal symmetry. If you rotate the viewpoint, the shape holds. Pareidolia usually breaks when perspective shifts because the pattern was never there. It was projected. This doesn't break. The platform measures roughly 4 meters across. The points extend 1 meter from the central body. The top surface is flat, worn smooth by current. The edges where the points form are sharp, not rounded. Natural erosion preferentially rounds edges because that's where mechanical stress concentrates. Water flow and particle abrasion wear projections faster than recessed areas. Pointed shapes degrade into curved shapes over geologic time. The turtle's points are intact. Either they're young formed recently, which doesn't match the 20-million-year-old Stone Age, or they're maintained somehow, or they're cut. No other formation on the monument matches it. That's odd for a natural process. You'd expect repetition if the same forces acted across the same rock type. Jointing patterns repeat, erosion patterns repeat, fracture patterns repeat. Unique features in geology usually indicate unique events, a specific fault line, a specific chemical intrusion, a specific impact. What unique event produces a 5-pointed star on one platform and nowhere else across 150 meters of monument? Number 7, the stage, an L-shaped platform, flat top, right angle in the bend, no taper, no rounding. It sits isolated like someone cut a section and left it. Erosion prefers curves. Water rounds edges over time. This stayed angular. Schoch says vertical joints and horizontal bedding create these shapes in sandstone, especially when earthquakes fracture the mass. He's right. But he also says it's not as regular as photos make it look. That depends on which photos. Some angles are perfect, some aren't. That split bothers both sides. If it's worked stone, why the inconsistency? If it's natural, why the precision where it appears? Geologists say joints aren't always visible at the surface, and tectonic stress can produce linear fractures that run for meters. True, but walls usually crack at irregular intervals. This one didn't. It stands intact. If it fractured clean and separated in one event, you'd expect matching planes on either side, like a broken plate where the edges fit. Divers haven't mapped that level of detail. Maybe it's there, maybe it's not. The Gosuntai, an isolated boulder resting on a low platform. It's large, it's centered. The boulder measures approximately 3 meters in length and 1.5 meters in height. Mass estimate puts it at several tons. The platform is flat and raised above the surrounding terrace by roughly 40 centimeters. The platform measures 4 meters by 4 meters. How did the boulder get there? If it rolled from higher ground, why did it stop on the platform and not tumble off? If it was placed, it weighs tons. Currents can move boulders during storms. Typhoons hammer Yonaguni. In April 1771, the largest recorded tsunami in the region struck Yonaguni. Waves estimated at 30 meters moved entire coastal sections. Coral blocks weighing 20 tons were found 200 meters inland after that event. A boulder could ride a surge and land, but landing centered on a raised platform is threading a needle. Tsunami deposits are chaotic. They scatter debris in lobate sheets. A single boulder deposited alone on a flat raised platform doesn't match known tsunami sedimentology. The base of the boulder sits flush with the platform, no void, no signs of settling. It's been there long enough for encrusting organisms to cover both the boulder and the platform edges, creating a continuous surface. That suggests stability over centuries minimum. How has the boulder stayed centered through multiple surge events? Either it's locked in place by weight and friction, or it arrived during a single event with precision that defies probability. Also comment from which city you're hearing this from. This script is factual, using evidence from Masaki Kimura's 15 years of mapping, published through the University of the Ryukyus, where he identified 10 distinct structures off Yonaguni and 5 related formations near Okinawa's main island, covering an area of 300 meters by 150 meters, totaling roughly 45,000 square meters of seafloor, and from the National Geographic article published online in May 2007, where Schoch and Kimura both presented their findings and measurements at the 21st Pacific Science Congress held in Okinawa that year, with both researchers submitting peer-reviewed abstracts. Additional sourcing comes from German geologist Wolf Wischmann's 1999 expedition organized by Spiegel TV and his 2001 follow-up expedition at Graham. Hancock's invitation both documented with underwater photography and rock sampling, and from Professor Patrick Nunn's analysis published in his work on oceanic geoscience at the University of the South Pacific, where he compared Yonaguni to other naturally occurring step formations across the Pacific Basin, including basalt columns in Hawaii and sandstone platforms in Australia. Now back to the information. The claimed carvings and symbols. Kimura says he's found quarry marks on stone faces. He says he's seen characters resembling Kaida script, pictograms used in the Yaeyama Islands southwest of Okinawa from the 16th to 18th centuries. Kimura says he's identified horse-like figures carved into rock surfaces at depths between 15 and 20 meters. He says there's a face that resembles a moai. He brought samples to his lab. He submitted documentation to academic conferences. Schoch says those are scratches, natural scoring from sediment dragged across rock by currents or from marine organisms. Parrotfish bite rock, leaving gouge marks. Urchins rasp surfaces, creating parallel grooves. Currents carrying sand particles abrade exposed rock, creating linear patterns. Neither man is lying. They're reading the same surface differently. The problem is, scratches and carvings look similar underwater. Incrustation covers both. Lighting changes interpretation. A groove lit from one angle looks deliberate, from another looks like a crack. Underwater photography compresses depth perception. No independent epigrapher has examined the site. Kimura's claims rest on his eye. Schoch's rejection rests on his. Without a third analysis from someone trained specifically in script identification, the evidence stays contested. A proper epigraphy study would require high-resolution photogrammetry, creating three-dimensional models of alleged carvings, then comparing those models to known Kaida characters. That hasn't happened. The last glacial maximum ended around 12,000 years ago. Sea levels were 100 meters lower. Yonaguni would have been part of a land bridge connecting to Taiwan. The East China Sea was a narrow bay. People and animals could walk the entire route. By 10,000 years ago, rising seas were flooding coastlines. Global meltwater pulse 1A, around 14,600 years ago, raised sea levels by 20 meters in less than 500 years. Kimura first dated the monument to 10,000 years old based on when submersion occurred. He examined stalactites and submerged caves near the monument. Stalactites only form above water. Some stalactites showed evidence of having been submerged, then exposed, then submerged again, suggesting multiple sea level fluctuations. Carbon-14, dating of coral attached to the monument, yielded ages around 2,000 to 3,000 years. Kimura revised his estimate in 2007 to 2,000 to 3,000 years old after presenting the coral data. But that only dates when the coral grew, not when the rock was shaped. If the monument is natural, it's 20 million years old. If it's worked stone, it happened above water before seas rose, which puts the window between 12,000 and 2,000 years ago. That's the Jomon period in Japan. The Jomon made pottery starting around 16,000 years ago, the oldest in the world confirmed by radiocarbon dating. They built pit houses. They had tools made from stone, bone, and wood. But their stonework was small scale. No Jomon megalith exists on record. If the Jomon carved Yonaguni, they did something unprecedented and left no trace anywhere else. Alternatively, humans modified a natural formation. Schoch says 95% natural, 5% human. But even 5% needs artifacts. None have been found at the monument itself. Human skeletal remains in Ryukyu Island caves date to 32,000 years ago. People lived here. They had culture. They worked stone, but nothing ties them to the monument. Critics say that absence is conclusive. Underwater sites lose material, yes, but not everything. The sea preserves shipwrecks and amphora and anchor stones. Bronze Age wrecks off Turkey retained pottery jars and copper ingots after 3,000 years submerged. If Yonaguni was a city or temple or quarry, the adjacent seafloor should hold scatters of worked stone or tool marks on nearby boulders. Quarries leave diagnostic patterns. Pavlopetri in Greece, dating to 3000 BCE, sits at similar depth as Yonaguni, and it has pottery scatters, stone foundations, and street layouts. Dwarka, off India's coast, has stone anchors and structural remains dated through associated pottery. But Yonaguni doesn't. Kimura argues currents swept it, or it's buried under sediment beyond the mapped area. He argues that wooden artifacts and pottery deteriorate underwater over millennia. Both are true, but stone tools don't. Ceramics, fired above 600 degrees Celsius, are durable. Stone flakes from toolmaking scatter wide and last indefinitely. The The surveyed area extends roughly 100 meters beyond the monument perimeter. Side-scan sonar mapped the seafloor topography. Divers conducted visual surveys. Remote-operated vehicles captured video at depths beyond recreational dive limits. No artifact concentration appeared. If Yonaguni was quarried, the waste has to be somewhere. It's not in the surveyed zone. The sandstone and mudstone fractured along bedding planes and joints that run perpendicular. Earthquakes propagated those fractures. The Ryukyu Trench generates magnitude 7+ events every few decades. Over millions of years, repeated seismic stress produces systematic fracture networks. Typhoons and currents eroded softer layers faster in carved steps. The monument's shape is a statistical clustering. Geologic forces produced rectangular forms across the island, but the underwater concentration got preserved because erosion acts differently below the surface than above it. The twin pillars are harder sandstone layers that resisted erosion while softer surrounding material washed away. The triangle pool's holes were scoured by vortex flow. The loop road follows a weak seam. The turtle is Pareidolia. The Gosentai rolled and lodged during the 1771 tsunami. The carvings are scratches from sediment abrasion and biological activity. The artifact vacuum proves no human involvement. This matches Schock's view in the 2019 Ogata study and Patrick Nunn from the University of the South Pacific, who says the formations are purely natural after comparing them to step formations in basalt at the Giant's Causeway and sandstone platforms along Australia's coastline. It solves the problem by denying the anomaly. The issue is, it requires every coincidence to land at once in a 150-meter span, pillars standing together with 3-meter spacing. A road wrapping 3 sides at consistent 5-meter width. A triangle with aligned 60-centimeter holes. A turtle with 5 points at 72-degree intervals. An isolated boulder centered on a raised platform, when multiple unlikely things cluster the probability compounds. Earthquakes fractured parts of it. Currents swept artifacts away over 10 millennia. This matches Kimura's view. It gives every feature a purpose, it explains the organization, but it creates a bigger problem. No other site from that period anywhere near Japan shows construction on this scale. Göbekli Tepe in Turkey dates to 9600 BCE, and it's the earliest known megalithic temple, but it's not underwater, and it left tools and carvings and bones. If Yonaguni predates Göbekli, it's rewriting prehistory. If Yonaguni is younger, say 3,000 years old, that's still 1,000 years before the oldest known Japanese stone monuments, which are small tombs and vessels, not pyramids. Where's the cultural continuity? Where's the tech transfer? A civilization advanced enough to move multi-ton blocks doesn't appear out of nowhere and vanish without leaving pottery or burials or camps. And the artifact vacuum isn't just a gap, it's a silence. No organic remains means no radiocarbon dates. No ceramics means no cultural markers. No inscriptions means no language evidence. For an artificial structure, the monument is archaeologically sterile. They carved a few markers. They maybe moved a boulder. They used it ritually or practically. Then seas rose and submerged it before extensive artifact accumulation occurred, or currents removed what little existed. This is Shaka's fallback, and it's the only scenario that doesn't require choosing between two incompatible truths. It allows natural geometry and human touch. It explains why features look deliberate, but artifacts are absent. The problem is, it's unfalsifiable. You can invoke it for any ambiguous formation. It hedges every bet. If you can't prove it's worked and you can't prove it's natural, just say it's both. That's not intellectually dishonest, but it's unsatisfying. And it still leaves the question, why here? If the Jomon or another group saw the formation and used it, why didn't they mark it more clearly? Why didn't they inhabit it enough to leave the trash heaps every human settlement produces? It was geological survey work. It should close the case, but it leaves the concentration question open. On land, the step formations are scattered. Underwater, they consolidate. Why? Visual identification of script is subjective. Kaida symbols are pictographic and abstract. A curve here, a line there. You can see them if you want to, or you can see cracks. He observed similar formations on Yonaguni's northeast coast above water. That's the control group. If the same features exist on land in the same rock type, and they're definitely natural, then the underwater version is probably natural too. The comparison is methodologically sound. Except the onshore formations don't organize into a unified platform. They fracture and tumble. The monument stayed stacked. If earthquakes fractured, both why did one collapse and the other cohere? German geologist Wolf Wichmann studied the site in 1999 during an expedition organized by Spiegel TV, and again in 2001 invited by Graham Hancock. He concluded natural processes could form it. Patrick Nunn, professor of oceanic geoscience at the University of the South Pacific, examined the evidence and said the formations are natural. Neither man had a stake. Both came from outside. Both said geology. That weight matters. Independent review leaning natural means the burden of proof stays on the artificial side. Until artifacts surface, or until isotopic analysis, or until excavation under controlled conditions with stratigraphy, none of which have happened, the monument defaults to rock. Schock says he knew it was natural the first time he dove. Kimura says he changed his mind after his first dive from thinking natural to believing artificial. Same site, same day, opposite conclusions. That tells you the monument doesn't declare itself. It makes you decide what tight angles mean, what aligned holes mean, what concentrated features mean. You bring your framework, and it either fits or it doesn't. The monument doesn't care. It's been sitting there for however long, 20 million years as stone, maybe 10,000 as shape, maybe 38 as discovery. It'll sit there after we're gone. Divers will keep coming. Currents will keep eroding. Earthquakes will keep fracturing. More features will collapse. Others will emerge. Somebody someday might find a stone tool wedged in a crack that radiocarbon dates to 9,000 BCE. Or they might find nothing forever. Either way, the monument stays silent, ambiguous, anchored to the bedrock 25 meters down where the hammerhead sharks still circle and the winter swells still howl, and the pressure at depth still makes your regulator hiss when you breathe slow and stare at walls that might be walls or might be fractures, and your brain makes the call because the rock won't. In 2007, Kimura presented his findings at the 21st Pacific Science Congress and revised his age estimate from 10,000 years to 2,000 to 3,000 years based on sea level data. That revision weakened his case. If the monument's only 3,000 years old, it's contemporaneous with known civilizations that left massive records. Where are they? Bronze Age. Japan has archaeology. Yayoi period sites have burials. If someone built a pyramid underwater 3,000 years ago, someone else would have written about it or tried to copy it or fled from its collapse. Silence again. Stylistically mimic the natural stepped features. That's evidence of inspiration, not construction. People saw the formation, they copied it on land, they didn't make the underwater version. That reading is parsimonious. It doesn't invent a lost civilization. It just says humans noticed and imitated nature, which they've done forever. The problem is, it still doesn't explain why the underwater formation is so much more organized than the onshore. Examples. Inspiration usually comes from the better version. If the natural steps on land are scattered and broken, why would you copy them instead of the clean underwater terraces? Unless the underwater version came first and somebody enhanced it, which loops back to hybrid. A road that wraps too consistently, a turtle too symmetrical, a boulder too centered, carvings too ambiguous, an age too contested, an artifact absence too total, a concentration too unlikely, a shape too architectural, a debate too entrenched, and a default to natural that doesn't quite satisfy even the people arguing it because you can see their hedge in the language. Schock says mostly natural. None says purely natural, but with a question mark in his tone. Ogata's paper says natural, but notes the concentration. They're right, but they're uneasy. Because when you dive the monument in person, when you drop through 25 meters of blue in the north face towers and you hover weightless, staring at a corner that slices 90 degrees and you fine along the loop road and it holds width, and you surface and you breathe and you try to tell someone what you saw, you can't quite land the sentence. You say it looked like, and then you stop. Because finishing that sentence requires committing. And the monument doesn't give you enough to commit. That's its nature. That's its mystery. It withholds the one thing that would settle it. The tool, the carving, the proof. And in withholding it, stays open. Forever. In 2025, the monument still has no official designation from the Japanese Agency for Cultural Affairs or the Okinawa Prefectural Government. No research grants, no preservation team, no excavation plan. It's a dive site, a tourist draw. Yonaguni Island receives roughly 1,500 visitors per year, mostly divers. Dive operators charge between 15,000 and 25,000 yen per dive, roughly $100 to $170 including boat transport equipment and guide. Winter season books out months in advance when hammerhead sharks aggregate and visibility peaks. The monument dive itself lasts 30 to 40 minutes, limited by current intensity and no decompression limits at depth. The debate happens in journals and documentaries and online threads, but not in the institutions that could fund the definitive study. Either nobody wants to spend the money on a formation that's probably natural, or nobody wants to risk the embarrassment if it turns out to be artificial and they missed it. Both are possible. Both are human. But neither is science. Science would settle it. Science would bring the magnetometer and the sonar array and the coring rig and the underwater stereo photogrammetry and the team that maps every square meter with millimeter accuracy and the years it takes to do that work right. Science hasn't shown up, not because the monument isn't interesting, but because the monument doesn't fit the grant categories. It's not a shipwreck, so maritime archaeology programs don't fund it. It's not a reef, so marine biology programs don't fund it. It's a rock that might be shaped and might not, and that ambiguity kills funding applications. Committees want clear research questions with testable hypotheses. Yonaguni offers neither, so it stays in limbo, documented but not studied, visited but not excavated, photographed but not modeled, debated but not resolved. The geologist who's spent decades saying it's a cliff, the independent researchers who've said natural, the enthusiasts who've said ancient, the governments who've said nothing, the currents that keep eroding, the earthquakes that keep fracturing, the hammerhead sharks that keep circling, the divers who keep coming, the cameras that keep rolling, the angles that keep being 90 degrees, the terraces that keep being flat, the absence that keeps being total, the question that keeps being open. The monument is what it is, shaped or broken, organized or random, old or ancient, used or untouched. It offers features that align just enough to trigger human pattern recognition and scatter just enough to frustrate human certainty. Not as answer, as question, as challenge, as mirror reflecting what we bring to it. All three views are legitimate, all three use evidence, all three reach different conclusions. That's not failure. That's complex systems, producing ambiguous outputs that don't declare themselves. That's stone existing where both natural and artificial explanations struggle, and closure requires evidence the phenomenon won't provide. 12 features, 38 years, no resolution, still asking, still waiting, still sitting 25 meters down where the current howls and your regulator hisses and the stone towers, and you hover trying to decide what you're seeing, and the stone doesn't help, and you surface with photos and measurements and opinions, but not answers, because the monument doesn't give answers. It gives data, and data without context is ambiguous, and context is what we argue about. And the argument continues, and the monument endures, and maybe that's the point. Maybe that's always been the point. In spring 2024, a team using remote-operated vehicles and high-definition sonar surveyed sections of the monument and found channels and platforms in areas previously thought featureless. The data hasn't been published yet. Maybe it'll shift the consensus. Maybe it'll deepen the split. Maybe it'll add a 13th feature to the list. Or maybe it'll just show more of the same. Geometry that looks intentional and could be accidental and sits right on the line where nature becomes ambiguous enough to let us project meaning, and that projection tells us more about what we want to find than what's actually there, which might be the monument's real function. Not a temple, not a quarry, not a natural bench, but a mirror, showing us how we think, how we choose, how we interpret stone when stone won't speak. That's what survives. That's what stays. Long after the debate ends, or the monument collapses, or the island subsides, or the sea reclaims everything we've built on land, the question remains. Not the answer, the question. Carved or cracked, made or found, proof or pattern. Yonaguni asks and doesn't answer, and that gap, the space between evidence and certainty, that's the monument. That's the mystery. That's what pulls divers through the current and academics into decades of work, and tourists across oceans, and skeptics into late-night arguments, and believers into conviction. The gap, the not knowing, the almost, the maybe. The 12 features that line up just enough to make you wonder, and scatter just enough to make you doubt. That's Yonaguni, 25 meters down, still waiting, still silent, still asking. And we're still here. Still diving, still arguing, still trying to make stone confess what it did or didn't do 10,000 or 3,000 or 20 million years ago when nobody was watching. And the only witness was the Pacific. And the Pacific keeps its secrets, and the monument keeps its shape, and we keep our theories, and none of them quite fit, and that's the point. That's always been the point. Not to solve it, to engage it. To stand at the edge of what we know and stare into what we don't, and admit we can't see the bottom. That's science, that's humility, that's mystery. And Yonaguni gives us all three, perfectly balanced, perfectly ambiguous, perfectly unresolved, just like us.